As always, it is just a pleasure to be working with you tonight. And welcome back. Welcome back to our second video. So you don't find these notes in the book, so you're going to have to take them from me. Finding the distance on a coordinate plane. It's much better to do this first than going into what the book does next, and that is the distance formula. So I'm going to show you how to find the distance between 2 points on a coordinate grid. And that's what the distance formula does when we come back for video number 3. But right now, we're looking at a coordinate grid. And we have these 2 points on this coordinate grid. We have points -2, 1, and we have point 4, 3. And there is a distance between them. We've drawn a line connecting those 2 points. And that is not a line that we can just count the distance on. We can't. So we're actually going to use Pythagorean Theorem to find the distance of that line. Well, what does Pythagorean's Theorem say? It says the sum of the squares of the legs is equal to the square of the hypotenuse. Well, I seem to be missing some parts of this right triangle. But I can create it. I can actually draw it on this coordinate grid. In other words, I can start at 4, 3. I like to go down. I can draw one above it, but I like to go down. And I can draw a line down to this point and then draw a line over to here, in which I now have formed this right triangle, in which I have a leg A, a leg B, and the hypotenuse. And I know how I can use that, because I can find those legs A and B on a coordinate grid by just counting the units. It makes it very simple. So I'm counting the distance between 4, 3 vertically and -2, 1, which is going to be this distance A. That's the vertical distance between those 2 points. That's going to be side length A. And if I count that, 1, 2, 3, 4, that is 4. All right? And then I can do the same thing on the horizontal distance on the coordinate plane, and I can count the horizontal distance between -2, 1, and 4, 3. And I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that one is 12. So now I have those 2 lengths, and I can use my a squared plus b squared equals c squared to find the distance between those by putting in 4 squared plus 12 squared equals c squared, 16 plus 144 equals c squared, 160 equals c squared, and then I would take the square root of 160, and ladies and gentlemen, I'm going to talk to you about it now, because there are some of you who have recognized that every once in a while your calculator would pop up what we call a simplified radical, because we recognize 160 is not a perfect square. So I'm going to simplify that radical. If I don't have a calculator, I can write a simplified radical answer, which would be 4 times the square root of 10. Because what I did is I took 160. I took 160 and I broke that up into 16 times 10. And then what I did is I took the square root of 16 and got 4. And that leaves me with an unperfect square of 10. So I'm given this simplified radical 4 times the square root of 10. And yes, that is something you will see next year in algebra. All right? Also, the square root of 160, which I want you to do to the nearest 10th, I'm not going to be asking you to write these simplified radical answers. I'm going to be asking you to write the answers to the nearest 10th. And that would be 12.64 when I round, and it goes on forever because it's not a perfect square. But we rounded to the nearest 10th, so I would go 12.6. Obviously, that is an approximation, because if that answer goes on and on and on forever, we don't have an exact, but you and I both know the distance of that line does come to an end. So we're just going to call it 12.6. Let's do a couple more. Find the distance between the 2 points by creating a right triangle, by drawing these legs in here, and then counting. I've got 2 there, and I have 1, 2, 3, 4, 5 there. So now I have 5 squared plus 2 squared equals c squared. That's 25 plus 4 is c squared. That's 29 equals c squared. And you and I both know to find c, we take the square root. That is the inverse of squaring. And so we would get an answer of 5.38, which when we round is 5.4 is equal to c. And we're just going to call it 5.4. Okay, moving right along. Example 8. Drawing another right triangle. Right here this time. And I count this side, 1, 2, 3, over here on the vertical, and 2 on the horizontal. 3 squared plus 2 squared equals c squared. 9 plus 4 equals c squared. 13 equals c squared. And I am going to find the square root of 13, and I find that to be 3.60, and there's more numbers. So we say 3.6 is equal to c. It's this simple. It's this straightforward. Recognizing that we have a vertical distance, a change in the vertical is going to be one leg, and change in the horizontal is the second leg, because this is leading us to the distance formula in our next video. One last time, drawing a quick right triangle in there, counting the side lengths. I have 2 vertical and 1, 2, 3, 4, 5, 6 horizontal. 2 squared plus 6 squared equals c squared. That's 4 plus 36 equaling c squared. That's 40 equals c squared. Finding the square root of 40, and the square root of 40 is 6.32. So, and of course it goes on. I only write down the first 2 digits because we're rounding to the 10th. So 6.3 is C. All right? Hopefully this is straightforward for you. If not, this is going to be one of the things you're going to ask some questions about tomorrow, isn't it? That's right. Moving right along to our quick right number 2, finding the distance between these 2 points, round to the nearest 10th. So I gave you a grid. You need to write these 2 points, draw them on there. The first one is going to be at -2, 0, and the bottom one is at 0, -4. So those are the 2 points. Draw them on your grid, and then, lo and behold, go to town. All right? We'll see you in a few minutes after you finish your quick write and take another quick snack.